Hello everyone, in this video we are going to solve a problem for vector summation. The question is asking for the value of F2 such that the resultant force acts along the positive x-axis and F2 has a minimum magnitude. So let's see what we know and what we don't know. We know the magnitude of F1. We don't know the magnitude of F2, nor its direction. It's a theta value. What about the resultant force? We don't know the magnitude, but we know the direction. It's going to act along positive x-axis. So let's form our triangle. We know F1, the magnitude and direction. F2, we don't know the direction. This could be F2, this could be F2, or any other direction. Nor we know the magnitude. But we know the resultant would be in this positive x. So if this is F1, these are options for F2. Could be F2, this could be F2, somewhere here could be F2, somewhere here could be F2, and then that would result in F4 in positive x direction. But the question gives us another information. F2 has a minimum magnitude. So for F2 to have the minimum magnitude, it has to be perpendicular. The shortest distance between 2 points is a straight line, is a perpendicular line. So F2, if I draw it here, F2 has to be perpendicular to be the shortest distance. And still we have FR, the resultant force, in the positive x direction. So that means that this angle is 60 degrees as is given to us here. We have the magnitude of F1, which is 800 Newton. And the question is asking for F2. So if we have 800, sine 60, which will give us F2. So F2 is 800 sine 60, which gives us 692.8 Newton. So we find a magnitude of F2. The question is not asking for FR, but if you want to find the magnitude of FR, that would be simply 800 cosine 60, which would be 0.5, so that would be 400 Newton. And we know the direction of F2, which is 90 degrees, because that's the shortest distance.